Okay, so before we move on to understanding the concept of arrays, let's first discuss the program uh, that has been given. So we have previously talked about function overloading. So basically, we already know what function overloading is. So let us just quickly revise a few points regarding function overloading, and then we'll move on to the program. So function overloading has certain special features or key features. The first feature is that all the functions that are overloaded have the same function name, and the second feature is that overloaded functions are differentiated uh, with respect to their function signatures. So we have already learned about these two features of function overloading. So overloaded functions have the same function name, and overloaded functions are differentiated with respect to the function signatures. So we are basically going to apply these two. We're going to apply this feature and this feature, or rather we are going to see the application of these two features in the given program. So let's take a look at the program now. Here, as you can see, they have clearly mentioned you have to overload a function. The name of the function is called series. So they have given you three different functions but with the same names as they are overloaded. So the series function has been overloaded thrice here, three times. So let us take a look at the first function signature. So as you can see here, um, this this particular function has two formal parameters. We have also talked about formal and actual parameters or arguments. So the values that are passed to the function in the when the function is called are called the actual arguments or the actual parameters, and the variables that we use to receive those values during the function call, as in the definition of the function, the first line, the function signature, we use certain variables to receive the functions that are, sorry, to receive the values that have been passed. So these are the formal parameters or the formal arguments. So take a look. First function series has two arguments. Um, the second function, the second version of the function series has just one argument, one integer argument, and the third version of series has zero arguments. So as you can see, this is an overloaded function. So the series function is an overloaded function, which has already been mentioned in the question. Now, how is it overloaded, or rather, how to differentiate between the overloaded functions or the versions of the functions that have been overloaded? So the first function will have two formal arguments, parameters. The second version of the function will have just one parameter, and the third version of the function will have zero parameters. So it does not take any parameters. So it's pretty easy from here on. It's pretty easy to implement this function. So let's try and write down the function. I'll not be typing the whole program for you. I'll just be um, explaining how to write the function. So let's just move on. Let's just move below. Let's just drag this screen over and let's just erase all these. And now, so they've asked you to design a class. So we'll be starting with a class. So let's call this um, okay. For before that, let's check if the function. Okay, so the as you can see here, there's one more thing that I forgot to mention. Um, the first version of the function displays the sum of the series as given below. So x1 plus x2 uh, plus xn. So this should probably be x to the power of 1 plus x to the power of 2 plus x to the power of n. So this basically I think is equivalent to something like this, x to the power of n. So to display the sum of this particular series where x is raised to the power of 1 starting from 1 up till n. So here there are two variables as you can see. So one variable is x and the other variable is n. So we do not know the exact values of x and n. Therefore they are going to be inputs. So x and n are inputs in the first version of the function series, and then we are going to use the mathematical function or math.power function to calculate the powers, or rather the each term of the series, and then we are going to display, calculate the sum and display the sum. Again, considering the second version of series, here also as you can see, mm, we have to display the following series up to p terms. So p is an unknown here. So p is again another variable which is going to be an input from the user. So p is input, and in the third series, or rather the third version of series, it's basically up till 10. So I have a final value. There are no variables in the third version of series. So there will be no particular inputs for the third version. But for the first and second version, we will be having inputs. So the first version will have x and n as input, and the second version will have p as input. The p is the number of terms in the second series, and n is the number of terms in the first series, and x is just a number. So again, for the first version of series, we are going to have to take x and n as user inputs as they are variables. In the second version of series, we have to take input for the variable p, where p stands for the number of terms in the series. And in the third version of the function series, there is no particular user input. Also, before we actually move on to the coding part, there's one more thing. Take a look at this series, this particular series. So let me write it down here. So it's 0, then 7, 26, 63, and so on up till p terms. So before we move on to the code, let's just decode this series. How are we actually getting each term? So in case of the first term, It's basically, uh, 1 cube minus 1 for the first term. Now the second term is equal to uh, 2 cube minus 1. So 2 cube stands, so if we can evaluate 2 cube, it will be 8 minus 1, which gives us 7. So 26 is equivalent to 3 cube minus 1. So 3 cube is equal to 27 minus 1, which gives us 26. Again, similarly, in the fourth term, it's again 4 cube minus 1, and this is basically the way that the series progresses. So 4 cube minus 1 is 64 minus 1, which gives us 63. So it's basically starting from 1, we have to find the cube and subtract 1 to get each term. Again, the next term will be 2 cube minus 1, followed by the next term 3 cube minus 1, followed by the next term 4 cube minus 1, and this will continue up till p terms. So here p terms means the number of terms. So it's not actually the value of this particular value, it's the number of terms in the series. So I have, let's say p is equal to 5. So I'll have 1, 2, so 1, 2, 3, 4, and one more term, which is 5 cube minus 1 for p is equal to 5. Okay. Similarly, for p is equal to 6, I'll have, so for p is equal to 6, I'll have one more term. So it will be 6 cube minus 1 for p is equal to 6. So the value of p determines the number of terms that I'm going to have in the series. So if p is equal to 6, then I'll have 6 terms. So this will be equivalent to 0, 7, this will be 26, 63, 125 minus 1, 124, 36 into 6 minus 1. 216 minus 1, which is equal to 215. So for the value of p is equal to 6, I'll have these 6 terms in the series. So 1, 2, 3, 4, 5, 6 terms. So that's how the second series works. The first and the third series are pretty straightforward. So in the second series, you would have to, use your brain a little. So you have to think about how you are getting the terms. So this is how you are getting the terms. You are cubing each term and subtracting 1 from the result, and we are getting the each term in the second series. So now let's move on to the coding part of the program. So now we'll write down the code. So let me just erase all this. So they've asked you to design a class. So we'll be starting the class. We'll be using the new format of class designing. So also, since we need, as you can see, we need inputs. Sorry. As you can see, we need inputs for the first and second series. So we'll be having an import statement. So import java.util.scanner. We are going to use the scanner class. Now we are going to write the code for the class. So let's call the class series overload, series overloaded. Now for the class variable, as you can see, each Sorry. So as you can see, 2 out of 3 series, we have to find the sum. So I'll be needing a sum variable. So that is a class variable that I'm going to define here. So mm, since we are working with integers, but we there are certain portions where we'll be needing um, floating point values. So the result will be a floating type. For example, in the series, in the third series, so in this particular series, the sum will be a floating type after calculation. So let's declare the sum variable as float. Let's use double so that we do not have to append an f after each value. So double sum. So this is a variable to store the sum of series. So I'm just defining one variable to store the sum because I won't be calling all 3 functions simultaneously. So at any one time I'll be calling just one function. I'll just be reusing this sum variable. So I'll just have a single sum variable. Now I'll write a constructor, or rather we could skip the constructor for the time being. Let's not write a user defined constructor. So the compiler will do it on its own. Let's directly move on to the functions. So first function would be for the first series, so the first version of series. So the return type is already specified in question as void, so we'll be using that. The name of the function is also given as series, and also the formal parameters have also been given to us in the question, so we'll be using those parameters itself. So remember, uh, whenever they give you the name of the function, the return type of the function, as well as the name of the parameters in the question, you have to reuse exactly the names that have been given to you. So here they have used intx and intn, so we'll be using the same intx and intn. Now we'll do all the work inside. So we already have the values of x and n, so we'll be taking input in the main function here. Let's assume that we already have the values of x and n inside these two variables. So what we'll be doing is um, I'll be doing it in one single line. So sum is equal to um, math.pow, rather, since we have to do it up till n terms, so I'll be needing a for loop for that. So for integer I, which is the for loop variable, I is equal to 1, so I is less than equal to n I plus plus. So why am I particularly starting the loop from 1 and running it up till n and increasing by 1 at every step? Let's take a look at the series once more. The first power of x is 1, the second power of x is 2, the third power of x will be 3, so it's increasing by 1 at every step. And n stands for the power to which x is raised. So this loop variable that we have used starting from 1 up till n will act as the power to which the value of x has to be raised. So the loop variable is the power to which x is raised. Okay, so inside the for loop, we have x, so I'll be directly using the sum. I'll be doing the whole thing in a single line. So math dot, sorry, sum is equal to sum plus math dot power x comma I. So that will essentially, uh, calculate the sum of the series for us. So in this particular line, we are calculating the sum of the terms in the series. So we are in this particular line, we are calculating the sum of the terms in the series. Now, that's all that we have to do. In the first version of series, that's just two lines of code, a for loop, and inside the for loop, we are just calculating the sum. It's pretty simple. So that is the first version of our series. So now let's take a look at the second version. So again, they have already given you the function header. So we'll be using that function header. So void series intp. So we'll be using that same function header. So void series intp. So here uh, again p is already an input. The input statements will be inside the main function later on. We are assuming that we already have a value in p, and we have to display display the series. So previously I was thinking of writing a different display function for the series, but let's just do it in here. So I'm just displaying, sorry, rather I'd have to do it outside the for loop. So in the, just let's just go back to the previous series function once. Here I have already calculated the sum. I'll just be displaying the value of the sum of the series. So SOPLN uh, sum of series plus the value of some variable. So I'm just displaying, calculating and displaying it in the same function itself. I'm not going to write a separate display function to display the values. Now let's get back to the second series version. So here um, again we'll have to write a for loop since we have several terms in the series. Again the for loop starts from 1. So for loop will start from 1. It will have p terms. So since it's starting from 1, it's less than equal to p and I plus plus. So there's one more, very interesting thing to note. I don't know if you have noticed or not. So in this particular series, which stands like this 07, 26, 63, and so on, the first term is 1 cube minus 1. The second term is 2 cube minus 1. So do you see the relationship? So the first term is the first, which means the first term is 1. The second term can be numbered as 2, and we are using 2 itself in the calculation. The third term is numbered as 3, and we are using 3 itself in the calculation. So we can do two things at the same time using this loop. So this particular loop will control the number of terms in the series as well as the value that we are going to work upon. So this particular loop variable does two jobs. So loop variable does two jobs. The first one is control the number of terms in series. The second job is uh, base value. Let's call the base value. Let's call each term the starting value of each term as the base value of each term in series. So by base value I mean this particular value. This is the first term. First term has a base value of 1. Second term, which is number 2, so 2 is the base value. Third term is number 3, 3 is the base value, which we are using to calculate the term itself. Okay, so that is what I mean by the base value. So the loop variable acts as uh, the loop variable basically controls the number of terms in the series as well as um, it also acts as the base value for the calculation of each term. So here I'll be using another integer variable. So I'll not be using the sum variable because we are not finding any sum inside the second version of series. So I'll be using a local variable int term which finds out each term is equal to math dot power I comma 3, since we are cubing each base value and subtracting 1 from it. So uh, there's one problem on using math.power here is that since we have an integer variable here, math.power returns a double data type. So we would again have to typecast if you use math.power here. So let's skip math.power and do it directly. So instead of you know doing math.power, we'll just be multiplying I 3 times with itself. So int term is equal to, so this is basically equivalent to doing math.power I comma 3. So I star I star I, this finds the cube of I, the current value of I minus 1. Also we have to display each term after calculation in the for loop itself, because remember the previous one was just the final sum of the terms, but here we have to display each term separately. So the SOPLN statement here will be inside the for loop because we have to calculate each term and then simultaneously display the term that we have calculated. So this is a series where we display the terms. This particular Series is a series where we display the final sum of the terms, but this particular series is where we display each term of the series. So SOPLN, we will display the value of term followed by a space, so that there's some space in between each term. So just a little bit of display formatting. Also, we could add one more SOPLN here, since we are formatting the display. So series, so we just so we just print a message here saying series, and in the next line we'll be printing each term of the series. So one more thing, there's one more mistake here. This cannot be SOPLN because I have to display the terms side by side. So this will be SOP instead of SOPLN. So if you do SOPLN here, it will print the term, go skip to the next line and print the next term at the next line. So we do not want that. We want it in a you know horizontal singular pair. So we want it side by side. So we'll be using SOP instead of SOPL. So SOP, and we are displaying the term followed by a space to separate the terms from each other. And that's all for the second version of the series function. Now let's take a look at the third version of series. So the third version of series again does not take any inputs or any formal parameters. It just displays this following sum. So this particular sum, it does not have any inputs also. So we are just going to start with 2. So take a look at the value which is changing. So this is the value that's changing. So first it's 2, then it's 3, then it's 4, and so on up till 10. So this particular value that's changed. So the numerator of the fraction, so this is a fraction, 1 by 2 is a fraction, 1 by 3 is a fraction. The numerator of the fraction in each case is same, it's 1, but the denominator of the fraction is changing at every step. So it's starting with 2, increasing by 1 at every step. So at the next step it's 3, again at the next step it's 4, so it's increasing by 1 at every step. So we are basically going to use this particular value. So we are going to use the loop variable to control this particular value since it's changing. So let's move on to the code. So the third version of void series does not take any arguments. It simply will have a for loop whose variable will start with 2, as we have seen in the series. It will go up till 10, including 10 last term, because the last term's denominator is 10, so we are using less than equal to, and it increases by 1 at every step. Here again we have to use the sum variable that we have previously defined, since we are finding the final sum of all the terms. So sum plus, and we don't need to worry because we have already defined sum to be a double data type, so we do not need to worry about the fractional part. So it will always you know um, calculate, it will work accordingly. So we are dividing, we are calculating fractional values, so it will just work fine. Sum plus 1 divided by I. So in the first iteration I will be 2, in the next iteration I will be 3, and in such a way we find the sum. So loop variable uh, rather instead of saying controls, let's say loop variable is equal to denominator of each term in series. Again, since we are interested in printing the final sum of the terms, so we do not need to have an SOP statement inside the for loop. So the for loop will end here and we'll have an SOP ln statement at the end of the for loop. So again, sum of series plus, we'll just display the value of the sum variable. And that's the end of the third version of the function series. And that's the end of our class. So the class series overloaded will only have, you know, these three functions and that variable. So we'll again define a new class. So let's call the new class program one. So there's one more thing that that was unnecessary is, since we are defining two separate classes, one class will have everything, and let's let's do one thing. Let's do it in the same class. Instead of having a different class, let's just define the main function in the same class itself. So we have already imported the scanner class. So um, after all the functions, so I'm just thinking about whether to use a different class. Hmm. Well, okay, let's use a different class. Let's not do it in the same class. So since we are not working with any inputs in the series overloaded class, since we are not working with any, okay, um, just hold on a second. Okay, um, okay, let's just use the same class. Let's not use two different classes. Let's stick with the same class. So java.util.scanner. Let's just define, write the main function in the same class itself. So it would work fine as well. So public static void main, just the usual definition of main. So string args. Next, inside, since we are going to have to take inputs inside the main function, so we'll have the scanner class. So scanner sc is equal to new scanner system.in. Now we'll just have certain input statements. So system dot out dot print enter the value of x and n for series 1. So this is pretty basic. So we have x now. Also let's take input for n as well. So sc dot next int. So now we have the values of x and n for the series 1. Now let's call the function for series for displaying the sum of the series 1. So before that, we forgot one more thing. We have to define an object of the series overloaded class. So let's just do it here. It doesn't make much of a difference. We had to do it here itself before writing this. And just after the scanner class, we had to define an object. But let's, since we have forgotten, let's do it here. So series overloaded object is equal to new series overloaded. So now we have an object. We will use the object to call the first overloaded series version. So I'm calling the first series function and passing two arguments x and n. For the second version of series, we again have to take an input. So system dot out dot print ln, enter the number of terms of series 2. Again we have to use a variable, so let's call it p itself. So int p is equal to sc dot next int. So we have the number of terms in the second series. Now let's call the second series function. So obj dot series with the value of p. So this calls the second version, overloaded version of the series function. And as for the third version, it does not have any arguments, or we do not have to take any inputs, so we'll just call it like this simply. So object obj.series with empty arguments. And that's the end of our main function and the end of our class. So this is the end of main, and this is the end of class. Also here we are calling the first version of series. Here we are calling the second version of series. Sorry, this line should be below. So this, in this particular line, we are calling the second version of series. So this is the second version, and just the next line we are calling the third version of series, calling the third version. Okay, so that's our whole program. So in the beginning we have defined the class series overloaded. We have defined the series functions, the overloaded series functions, first version, the right. So this is the first version. This is the second overloaded version. So this is the first overloaded version, and similarly, this is the third overloaded version. So we have three series functions which are overloaded. Next, we have the main function where we are taking inputs and calling the respective functions, and we are getting the outputs. So that's all about the coding portion of the program. So in the next video, we will be talking about arrays.